So we will be now discussing about the very last unit or last portion of the syllabus, integral calculus 2. Usually the topic curve tracing is labeled as integral calculus 2, right? So in the previously unit number 1, I think it was integral calculus 1, wherein we talked about improper integrals, and usually we call them in mathematical terms alpha, beta function and gamma function, right? So gamma function is also treated as an improper integral. Integral wherein one of the pair of limit is an infinity, and whenever such a improper integrals are there, finite integral is a finite quantity or a fixed value as an answer, right? So that was all what we have discussed in integral calculus 1. This integral calculus 2, we will be dealing with the curve tracing. Now what do we understand by the curve tracing, or what was the philosophy to introduce this particular topic in the discussion of mathematics 2? Very many of the curves are familiar to you, right? The equation of a circle is given by x square plus y square is equal to a square. The parabola is given by y square is equal to 4ax, right? These are all known functions or known equations, and appropriately you can visualize the figure or the diagram for this particular given equations, right? How the curve y square is equal to 4ax will be, it will be a parabola like this, which is symmetrical about the x-axis. Y square is equal to 4x. In the examples of the multiple integral also, while calculating the region which is bounded by the given lines or the curves, we usually try to draw the rough sketch. So in addition to it, whenever the curve is familiar to us or we know it very well, we can easily draw the rough diagram so as to interpret the given region of integration. Once that is done, we can easily draw the strip. So this was one of the figure wherein we have the equation as y square is equal to 4x. This is particularly the parabola which is responsible for the curve x square is equal to 4ay. It is symmetrical about the y-axis. The parabola y square is equal to minus 4x will be drawn in this way. The parabola x square is equal to minus 4ay will be drawn in this manner, right? The equation of a circle is x square plus y square is equal to a square, whose center is origin and radius is equal to a or say r. So I directly draw the figure because that is particularly a known equation to me. The equation of ellipse is given by x square by a square plus y square by b square is equal to 1, and that is what is in oval shape form, wherein we have the coordinates on the x-axis as a comma 0 and the coordinates on the y-axis as 0 comma b. So this is what you have learnt in conic section of your 12th standard or the junior college level, where these particular curves were mostly discussed and several properties were known. But my job in this particular unit to learn is, irrespective of any of the equation, I should be able to visualize and have the diagrammatic representation for that given curve, and that is what actually is a curve tracing, or we are drawing it actually depending on various parameters to be fulfilled. So curve tracing, just looking at the given equation of the curve, I cannot draw it, right? There has to be certain set of rules or the parameters which are to be validated or checked first depending on the nature, and then we will be analyzing the things so as to get the hint for drawing the particular curve. So the equations can be distributed or can be classified into three different forms. One of the major form usually in practice is Cartesian coordinate system, wherein we have the variables into picture as x comma y. So whenever I am drawing the Cartesian coordinate axis, that is x versus y, usually the variables taken into consideration is x and y. The other set of coordinate system from Cartesian to other transformation, by using the transformation as x is equal to r cos theta and y is equal to r sin theta, I get the polar coordinate system where function is function of r as well as theta. The third coordinate system, or in which the transformation can be done, is parametric equation or the equation in the parametric form, wherein both x as well as y are functions of a parameter or a single variable, and those particular equations are identified as parametric equation. So in this particular unit we will be discussing about drawing of Cartesian curves, polar curves, and the parametric curves, right? And after that certain applications are to be discussed, like calculation of area, calculation of length, calculation of volume, etc. So this is all what the complete portion or the contents of the syllabus will be classified into. My major focus will be on Cartesian coordinates system. Later on I will be discussing about the polar, and lastly the parametric. As per the new guidelines, there have been restrictions on the discussion of polar and parametric. In the polar only we will be limiting ourselves to the cardioid, the four different types of cardioids we come across, that is r is equal to a into 1 plus cos theta, r is equal to a into 1 minus cos theta, r is equal to a multiplied by 1 plus sine theta, and r is equal to a multiplied by 1 minus sine theta. In the parametric we have one figure which is called as an asteroid, whose equation is given by x to the power 2 by 3 plus y to the power 2 by 3 is equal to a to the power 2 by 3. That is what we are going to talk about. But in Cartesian, any type of the equation can be given to you, and our job will be to discuss in detail about the various parameters and then decide how the figure will look like. So before switching to the actual discussion or the portion to be checked, or the parameter set of rules to be checked for the drawing of the given particular figure, we just look at the background and the types of curves, and then we try to solve the given examples wherein various equations will be provided to us, and we will be intentionally trying to draw them appropriately. Now whenever the relationship between the variables x and y is other than first degree, because whenever the variables appear in the first degree we call that particular expression having the linear relationship between the variables. But whenever this particular degree or power exceeds 1, that means it starts from 2 onwards, that particular equation is no more a line, it converts to a curve. It will never be exhibiting the relationship as a linear, and if you draw it, it will not be a straight line, but it will turn into a curve. So all the variables having degree or power other than 1 will be termed as a curve. So in general we will be provided with such kind of equations, and therefore the topic is, or the heading of our topic is, curve tracing. So what was the necessity and what actually the curve tracing is, we see it in the short, and then try to discuss about different types of curves and various terminologies associated with it, so that it will be very easy for us to discuss the other points for the simplification of any given problem. So tracing of a curve is an analytical method of drawing an approximate shape of a curve with the help of its characteristics. Knowledge of curve tracing is useful in application of integration in finding length, area, volume, and surface area. Now, what are different types of curves? I told you that they are classified into three. One of the category is Cartesian equations. The equation which are functions of Cartesian coordinates x and y are termed as Cartesian equations. For example, we have the parabola, the standard parabola, y square is equal to 4ax. This particular equation contains the Cartesian coordinates x as well as y. Second one is parametric equations, the equations in which x and y are functions of third point, or usually a parameter theta, where this particular common variable is called as parameter. Such equations are identified as parametric equations. For example, the equation is given by x is equal to a cos theta, y is equal to b sin theta, are the parametric equations of ellipse. What actually the ellipse is given by or denoted by in Cartesian form? X square by a square plus y square by b square is equal to 1. If you remember, this particular point A the constant A is plotted on the x-axis. This is plotted on y-axis. It is taken as a coordinate 0 comma b. So therefore x is always associated with the trigonometric term cos, y is always associated with the trigonometric term sine, and therefore the parametric equations for the ellipse x square by a square plus y square by b square is equal to 1 is x is equal to a cos theta and y is equal to b sine theta. The third category is polar curve. The equations which are functions of polar coordinates r as well as theta, we say that it is particularly a polar curve. R is equal to a into 1 plus cos theta is identified as a polar curve because it is containing the variables r as well as theta. The next terminology or the concept to be understood is double points. This particular category or the definition of double point will be in our one of the set of rules which we will be following to determine the nature of the curve as well as to get the points so as to draw or plot the given diagram. So what actually the double points mean? Those are actually the tangents which are intersecting or passing through the origin. The tangent to any particular given curve, if they are meeting at origin, or the type of the tangents the equation is obtained, depending on that we can clarify whether it is going to be a category 1 or category 2 or category 3. These categories are labeled as node, cusp or tack node, and third is conjugate or isolate points respectively. So what actually double points mean? Double points की definition देखते हैं. If there are two tangents at the origin, then origin is called a double point. If for any particular given equation of the curve I am able to get two tangents to that particular given curve at origin, we will say that it is a double point. At double point, two branches of the curve pass. There are three different kinds of double points. Number one, it is identified or called as node. If at the origin there are two tangents which are real and different, then origin will be a node. Now the question arises how to get this tangent. The rule will be specifically given in the set of procedures or the steps what we will be following, that how to determine the tangents. If those tangents appear to be real and different, we say that it is node. Now how they will be? Because they should be minimum in two quantities, because double point kisko bolte hai? When there are two tangents which are at the origin, and those double points can be later on subcategorized into node, cusp and isolated point, right? So if at the origin there are two tangents which are real and different, origin is a node. The figure will look like this because two tangents are intersecting at a particular point, that is origin, for the given curve. Cusp, or which is also called as tack node, it if at the origin there are two tangents which are real and equal. In the first case they were real and different, now they are real and equal, they are supposed to be real and equal. In that case we say that it is a cusp. Real and equal means one and the same line, they will be coinciding with each other, there won't be two different lines visible. So therefore in that case I say that it is a cusp and it is drawn in this way. Or the other possibility can be this is a simple single tangent wherein it is coinciding and these are the curves which are drawn, and we call it as a tack node. Lastly, the conjugate or isolated point. If at the origin there are two imaginary tangents, origin is a conjugate point. Imaginary tangent means the values are not real. That means it is involving the imaginary number I, and therefore which are beyond our purview or imagination. Those particular points will be imaginary points containing I. In mathematical language, the term containing imaginary number is the equation containing I will be referred to as an imaginary tangent which we can easily identify, and that will be the conjugate or isolated point. Cannot be drawn or shown in the given curve or the given diagram. So this is all regarding the double point, wherein we will be categorizing them into the three different parts, namely node, cusp, or tach node. Lastly, it is the third is conjugate or isolated point, but very rare chances in which we occur with this conjugate or isolated point, because depending on the nature of tangent, uh, lot many a lot many points are dependent so as to draw the given curve, right? How the figure will look like. Now, without wasting much of the time, we try to understand or learn the procedure for tracing the Cartesian curve which is given by. Now, Cartesian coordinates or Cartesian curves will surely involve x and y, but there might be two different possibilities. Either y is expressed in terms of x, or x is expressed in terms of y, or in general I can say f of xy is equal to 0. So how to determine that the given curve is a Cartesian curve? Either it is written as y is equal to f of x, or x is equal to f of y, or f of xy is equal to 0. So these are nothing but the Cartesian curves. We have to abide to these 7 steps for determining or drawing a given particular diagram for the given equation of the curve. Number 1, the first point to be checked is symmetry. What does this symmetry means? This symmetry, either it will be about the x-axis, or it will be about the y-axis, or it will be about the origin, or the other option can be it is about both the axes. So how to check the symmetry? Whether the curve is symmetrical about which axis, whether it is symmetrical about origin, or whether it is symmetrical about both the axes. It purely depends on even power of the variable. If in an equation the curve contains even powers of y, then it is symmetric about x-axis. Vice versa होता है हमेशा. जब even powers y के रहेंगे तो curve will be symmetric about x-axis. For example, y square is equal to 4ax, which is very familiar equation to us. The curve will look like this. आप अगर देखोगे, this is symmetrical about x-axis. कौन से वेरिएबल के पावर्स इवन है यहाँ पर? y के. तो सिमेट्रिक अबाउट कौन से एक्सिस होगा? x एक्सिस होगा. इसी का अगर रिवर्स करते हैं, सिमेट्रिक अबाउट y एक्सिस होने के लिए क्या होना चाहिए? इवन पावर्स ऑफ x. So the immediate next point comes is about y-axis. How to check the symmetry about y-axis? If the equation of the curve contains all powers of x as even, then it is symmetric about y-axis. The best fit equation is x square is equal to 4ay. This is particularly the diagram of this given curve, which shows that it is equally distributed about or along the y-axis, and therefore we say that the curve is symmetrical about y-axis. But there might be certain equations in which both the powers of x as well as y are even, so those will be termed as, or those will be referred to as, symmetrical about both the axes. What can be the best equation for that? X square plus y square is equal to r square. This represents a circle with center at origin and radius equal to r, and therefore it is evenly distributed above x-axis, below x-axis, on the left of y-axis, and on the right of y-axis. So when we term that curve is symmetric about both axes, if the powers of both x and y are all even, then the curve is symmetric about both axes. Equation is x square plus y square is equal to a square. About origin, how to check whether the curve is symmetrical about origin? Replace x by minus x, replace y by minus y. If still the equation of the curve remains unchanged, I can say that the curve is symmetric about origin. If x is replaced by minus x, y is replaced by minus y, equation remains unchanged, and therefore we conclude that curve is symmetric about origin. और सॉरी, यस इट इज अबाउट origin हो गया था क्या? नहीं, यही origin के लिए है. बोथ एक्सिस के लिए क्या था, बोथ पावर्स ऑफ एक्स एज वेल एज वाई आर even, right? Then once we have identified that curve is symmetric about x-axis, y-axis, or origin, or both the axes, we try to know the nature of origin. The second most important point is nature of origin. What does it says? Put x equal to 0 or get or find out x equal to 0 for y equal to 0 if it satisfies the given equation. Means in a given equation, if you are putting x equal to 0 and you are obtaining the answer as y equal to 0, that shows that one of the point of intersection for the given curve is origin. That means it passes through origin. So find out x equal to 0 for y equal to 0 if it satisfies the given equation. For the curve y square is equal to 4ax, putting x equal to 0 gives y equal to 0. Curve passes through origin. If the equation does not contain any constant term, then the curve will pass through origin, otherwise not. How this can be justified? The equation of a line is given by y is equal to mx plus c. The standard form of the equation of line is y is equal to mx plus c. This contains a constant, arbitrary constant c, and therefore such type of lines will never pass through origin. Those will be displaced from the origin. But if I remove this c from the equation, it remains y is equal to mx, and we are all aware that the equation y is equal to mx represents a line which passes through origin. So another way of determining whether the given curve passes through origin or not is, first thing you need to check whether any constant exists in the given equation. If yes, it will not pass through origin. क्योंकि आप इसमें अगर x को भी 0 पुट करते हो तो c plus 0 क्या बनेगा, c. Y is equal to c. I am not getting y is equal to 0, so I am not getting or meeting the requirements for the coordinates of origin. So therefore this particular curve will not pass through origin, right? Third point is, abhi nature of origin pata kar liya. I want to know whether how are the tangents at the origin, because those double point concept or equations what we have discussed, whether it is a cusp, whether it is a node, whether it is a conjugate point or isolated, that will be identified over here. Once you know the tangent at origin how they are, we will be easily knowing whether the figure to be drawn in the form of a node or a cusp. The equation to tangents are obtained by equating to 0 the lowest degree term or terms of the given equation. From the complete given terms present in an equation, whichever are the lowest degree terms, may it be for x, may it be for y, equate them all to 0. See how the equation appears. Surely tangent is nothing but the straight line. You should get the equation in the form of a line, linear relationship, and then we identify that those are nothing but the tangents. The equation to tangents are obtained by equating to 0 lowest degree term of the given equation. If suppose you are provided with the curve as y square is equal to x square minus x to the power 4, which are the lowest degree terms, x square and y square. So y square minus x square is equated to 0. You get y square is equal to x square, y is equal to plus minus x. These are nothing but the equations of tangent at the origin. Now those are real and different. Real and different के लिए क्या होता है, cusp होता है. So accordingly we will be drawing the shape of the figure in that way. Next is identifying the intercepts. How intercepts are obtained? X intercept is obtained by putting y equal to 0. Y intercept is obtained by putting x equal to 0. So put y equal to 0 in the given equation, solve for x, we get a point in which curve cuts the x-axis. Put x equal to 0 in the given equation, solve it for y, we get a point in which curve cuts the y-axis, right? So in this manner we will be getting down the intercepts. The next point, that is fifth point, is asymptotes. Identify whether the curve has asymptotes or not. What actually this asymptote mean? An asymptote to a curve is a straight line which is tangent to the curve at infinity. infinity यानी किसी ने भी नहीं देखा है कहां तक वो tangent जाएगा for any given curve, but वो exist करता है या नहीं for the given curve कैसे पहचानेंगे? It is nothing but a sort of a straight line which is actually a tangent to the curve but at the infinity. यानी जब तक अपन फिगर में देखेंगे वो कभी टच नहीं करेगा because it is touching or it is tangent to the given curve at infinity. Now tell me how infinity is obtained. Whenever denominator of any given fraction turns out to 0. So suppose I have the equation y is equal to f of x upon x minus a. Denominator कब 0 होगा? When x will be equal to a, and when denominator is 0, y will be tending to infinity. So what equation is responsible for getting the asymptote for this given y? X is equal to a is a line which is responsible for converting this y to infinity or y tending to infinity. So this particular line, since it is going to be a tangent, it is a part of a line or sort of a type of a line. So x is equal to a will be treated as an asymptote. तो जिस पर्टिकुलर फिगर में या कर्व में डिनोमिनेटर किसी वैल्यू के कारण 0 बनने के चांसेस है उसको बोलेंगे एसिम्प्टोट फॉर द गिवन कर्व, क्योंकि उससे आपका जो गिवन कर्व है वो इंफिनिटी के तरफ टेंड होता है. Now here if you mostly see I am taking y as a function of x. तो ज्यादातर मुझे आदत क्या है कि गिवन कार्टेशियन कर्व को मैं x is equal to f of y भी लिख सकता हूं, but I will be taking it as y in terms of x because we are habituated in solving such kind of equations, or in practice we have come across with such kind of curves, and therefore in Cartesian we always focus on expressing the given equation in the form of x, y expressed in the form of x, right? And therefore all these calculations are done in that way. So keeping y on one side and transforming or shifting the other values of x or other portion of the equation x to the other side, right? The next point, the sixth point is region of existence. वो कर्व का कहां तक बाउंड्री या एग्जिस्टेंस है वो मुझे पता करना है. सो इफ द वैल्यू ऑफ y is imaginary for certain values of x, then the curve does not exist for such values, right? Now how y can be imaginary? जब square root of a negative number होता है we say that the imaginary number I is introduced. So for those all values of x which will be negative or which will be mathematically written as less than 0 will be turning out or giving us the value of y as imaginary, और वो पॉइंट्स के लिए कर्व नहीं ड्रॉ किया जाएगा. So for those values of y, certain values of x which make it imaginary will not be considered, and therefore कर्व का बाउंड्री जो है वो वही पॉइंट्स तक लिया जाएगा. What is the last point? Plotting the given points and joining them, we draw the given curve. So these are all 7 different points or the steps or the